When we have a variety of different transformations going on inside of one function, the order in which you perform the transformations is really, really important. There's a couple different ways you can think about the order. So if you've taken a class before and learned a certain way of remembering the order of transformations and you stick with that and it works, great. But the one that's in our textbook, we have you do any horizontal shift first. Remember, a horizontal shift is when you add or subtract a number to the x inside the parentheses. Then you do any stretching or shrinking. Remember, stretching or shrinking is when you either multiply a number times the outside of the function, or you multiply the number on the inside of the function. If it's on the outside, you get a vertical stretch, or a vertical compression if the number is a small fraction, or if it's on the inside, you get a horizontal stretch or compression. If the number is bigger, you get a compression. If the number is smaller, between 0 and 1, you're going to get a stretch actually away from the y-axis horizontally. And then next, you're going to do any reflecting. Reflecting occurs when you have a negative out front or a negative inside the parentheses. So this would be a, remember when we negate the y, the f of x is just y, so when we negate the y, that's going to give you the a reflection over the x-axis, and so that's called a vertical reflection. And if you negate inside the parentheses the x, this is going to give you a horizontal reflection. And then lastly, you do your vertical shift, and that happens when you add or subtract outside of the parentheses, outside of the function. Okay, so let's look at a couple of examples where we have a combination and see how we would work with that. So for example, what if I asked you to graph f of x equals 2 times x plus 1 squared? Since I'm not just giving you the graph, but I'm giving you the equation and expect you to know the parent function, the first thing you would need to do is to identify which parent function from our library of functions. So the key here is the square, right? So if I look at my list of functions from my library of functions, we know that it must be a variation on this function, x squared. And remember that we have 3 key points that we're always going to use for x squared. We're going to have 0, 0, 1, 1, and negative 1, 1. And we're going to want to see what happens to these 3 key points. Now that I know that I'm going to use the parent function x squared, and that I'm going to be interested to see what happens to 0, 0, 1, 1, and negative 1, 1. Okay, now I'm going to identify what types of transformations I have. I have 2 differences between this function and just x squared, right? First of all, I'm adding 1 inside of the parentheses, and also I'm multiplying by 2 on the outside of the parentheses. So you have to know what kind of a transformation what kind of an effect that's going to have. We know that anything that happens on the inner part of the function is going to affect the x coordinate, and it's going to do so in the opposite of the way that you would expect. So in this case, since it's plus 1, you're actually going to subtract 1 from each x coordinate. Okay, and then whenever something happens on the outside of the function, that affects the y coordinates. And in this case, it's going to multiply 2 times each y, which is going to have the effect of stretching it. So this one over here, the subtracting 1 is going to affect, it's going to give us a horizontal shift. And doubling each y coordinate, what kind of effect is that going to have? So that's going to stretch the function vertically, right? Vertical stretch. All right, so let's come back over here and see what we've got is a horizontal shift and a vertical stretch. So that is number 1 and number 2. So we're gonna shift horizontally first, and then we're gonna do our stretch or shrinking. All right, so let's start by performing our horizontal shift, which is subtracting 1 from each x. So when we shift x squared horizontally, we end up at negative 1, 0, and we end up at subtracting 1 from 1, we're going to get 0, 1. And subtracting 1 from negative 1 is going to give us negative 2, 1. All right, let's go ahead and plot that to see where we are. This is just the first step, horizontal shift affecting the x-coordinate. Okay, so we are at, so far, negative 1, 0, 0, 1, and negative 2, 1. Let me zoom in a little bit more. Okay, so negative 1, 0, 0, 1, negative 2, 1. You see how that looks like the parabola that we're familiar with, but it's shifted to the left 1 unit. This would be the graph of y equals x plus 1 squared without the 2, okay, because we took care of the horizontal shift. But now we're going to take care of the stretching by a factor of 2, which just means that we're multiplying each y coordinate by 2. So I'm doing this in a separate step so that I make sure that I do it in the right order. And what I'm going to do is multiply each y coordinate by 2. So for example, the point negative 1, 0 is going to end up being what? Still negative 1, 0. The point 0, 1 is going to be 0, 2 when I double the y coordinate, 0, 2. And the point negative 2, 1 is going to be negative 2, 2. So let's go ahead and plot those points. Negative 1, 0 stays the same, it doesn't stretch. But 0, 1 is going to become 0, 2, doubling the y coordinate, and then negative 2, 2. And so we get this graph. It's supposed to be a nice smooth round curve, let's all pretend. Okay, so you notice that it looks kind of skinnier, but really what the way we're thinking of it is as a vertical stretch. So it's getting further away from the x-axis. So this graph in blue, that's our f of x. So that's what I mean by performing it in this particular order, because in some cases, depending on the combination of transformations, if you perform it in the wrong order, you'll end up with the wrong graph. But I want to reassure you that you can always check, because if you got it right, these final points, negative 1, 0, 0, 2, and negative 2, 2, those final points should satisfy the equation f of x equals 2 times x plus squared. So let's just check. For example, if I plug in negative 1 to f, I should get 0. Let's see, negative 1 plus 1 squared. So we get 2 times 0 squared equals 0. So yeah, it should go through the point negative 1, 0. If I plug in 0, I should get 2. Let's see. F of 0 equals 2 times 0 plus 1 squared. It's 2 times 1, which is 2. So that worked as well. And we have f of negative 2. 2 times negative 2 plus 1 squared. It's going to be 2 times 1, which is 2. Okay, so that one worked as well. So in the end, after you do several transformations, if you're not quite confident, you can still just plug in those values. So why do we need to specifically move these key points? Well, because those are where important changes happen in the function. So if we just randomly graphed points, we might get a part of the function that's off to the side here that maybe looks like a line. We don't actually get the important part, which is the part where it turns around. We need to be able to see the shape of the function. I hope you found this video useful. If you did, please remember to like it.